Okay, first of all, we have several minutes before we start, because maybe somebody else will come. So I will use it first to say hello, good afternoon. It's number one. Number two, I'd like to tell you that my name is Alexander Durandin, and I'm from chemistry department, NYU. But today I will speak about physics. This presentation is about physics. And I remember that we are in Courant Institute, which is Mathematics Institute. So one thing is, of course, to tell you something about Doppler. Because Doppler effect finally is in high school, and so those of you who will take like AB physics must know Doppler. So I will, of course, teach you about Doppler. It's not a big deal. You remember that Doppler is the basis for all radars, sonars, GPS. Like ultrascan when you have baby on whatever, it's all based on Doppler effects. Plenty other things. I would say almost half of the electronic devices are based on Doppler effect. So remembering one formula like this, it's not enough. It's much better if you understand what's behind it. And so I will try to teach you, to teach not to remember formula, but to understand. In order to understand, sometimes in mathematics especially, people explain what is abstract thinking. It's something close to whatever computer thinking. So it's wrong. If you want abstract thinking, it means that you should absolutely accurately in your mind imagine how would you do experiment. Because you can write all kinds of equations. You write this equation, you remember it, it's fine. Who will tell you that's wrong? It's fine. But try to do experiment, and you will see it's wrong. Sometimes it's correct, sometimes not. In order to understand that, you have to understand the whole thing. How idea was born, how it was checked, who did experiment, what kind of experiment. When you imagine all that stuff, only then you can understand how can you apply it and whether it's correct or not. So, besides Doppler effect by itself, I would like you to understand methodics. Methodics of being able to understand it. And of course, one more question will be, what is the relation between mathematics, physics, and some other sciences? So, I would like you to give example. For example, 1 plus 1, how much? 2. For mathematician, correct? But for physicists, it depends. Let's say 1 kilogram plus 1 kilogram. According to Einstein, 1 kilogram, when it's longitudinal, is not equal to 1 kilogram transverse. They are different. You can take open theory of relativity, it's like 5 pages, small publication, and you will see. So 1 plus 1, it's not 2. It depends on the speed on the Earth. So 1 plus 1 equal to 2 only at the center of universe. On the Earth, here, 1 plus 1 could be whatever. And if you in spaceship accelerate a little bit, let's say close to speed of light, 1 plus 1 could be million, billion. You understand it? So why I talk about this? Because mathematics is instrument as a science. It's not absolute science. It's not valid for itself. Whatever mathematical equation you take, first of all, it's based on physics, on nature, on our environment. So there is no one single mathematical rule that is correct without physics. Of course, mathematics sometimes explain it, but in most cases not. They simply tell you that 1 plus 1 is 2. And then you have to remember. But when you ask, what about relativity? And they will tell you, oh, when you graduate from university and go to graduate student and prepare your PhD, then you learn in mathematics there are such ideas as Hilbert space. It's space which is nonlinear. in this space, 1 plus 1 is not 2. Not in the distance, not in the mass, and so on. Anyway, it's time to start. We waited not... Oh, he just checked that I'm here. Anyway, it's time to start. What I would like you to pay attention to, not only to formulas, but to approach, to method. Okay, so today's presentation is called Doppler Theory and New Approach to the Doppler Theory. I'll try to do it at the level of the high school. So if I use any word, terminology, or something that you don't know, please interrupt me immediately. Just, I will explain you what I mean. If you open the book, physics, it doesn't matter high school or university or whatever, you will see the Doppler effect is described by this one formula. So if you remember this formula, that's enough for you to pass exam, both at school, at university, anywhere. In this formula, this F is a frequency which is observed by detector. This is a frequency at the generator, original frequency. This is the speed of the detector. This is the speed of the wave, and theta is the angle between V and C. So if you can remember, good, but imagine 20 years later, will you remember? Especially if you do not deal with this. Probably not. Unless you will understand it. Because when you understand, you can easily reproduce it once more. So let's move a little bit and try to imagine what do we mean. So first of all, this formula has deal with the wave. Do you know what is wave? Wave is any periodic process. It's something that repeats itself. One over and over and over. In simplest case, it is like this. This wave is called sinus. I hope you know what is sinus, cosinus, no? Trigonometry should be at school anyway. So this is a graphic. Blue line is a sinus line. It's periodic process. The distance between two maximums is called wavelength of Mach lambda. The time which needed for the wave to come from here to here is called period of the wave. And so this is the wave. Now let's try to reconstruct what Doppler thought when he started his experiment. If you try to look at the publication, you will see stars changing the color of the stars, and it will not create a good idea. So, in order to imagine, as I mentioned, it's very important to see this picture in front of your eyes. Imagine yourself in a boat. So, there is ocean. There is ocean, you see? And you are in the boat. Now, when boat, let's say these waves come ashore. When you travel against waves, you hit it very, very often. When you travel in the boat along with the wave, what shall be? So try imagine surfer. Surfer stay on the wave and come and cross no one wave. He comes back with one wave, correct? So number of the wave that he will face during his trip to the shore will be much smaller than when he goes back. And that's what Doppler noticed. He was not surfer, but he was using rowboat. And he noticed that when you go from the shore to the ship, he hit much more often these waves than when he came in the back direction. So now, this observation, it's physical observation or basis for the science. In order to make it science, we need to make mathematical expression. So how we transfer idea into expression? We do experiment. We take, this is a frame, it's detector. What detector does, it counts. It counts maximums. You see, each one wave has a maximum, and here minimum. So, when wave comes through the detector, it counts each one maximum. 1, 2, 3, 4, 5. Now, at the time 0, we start our experiment, and we count how many waves pass through this detector. in order to put it into formula, mathematical expression, we do following. Since speed of the wave is called c, remark c, during time t, the distance, this is the distance that wave passed, is equal to speed times time. Correct? If you don't agree or don't understand, please tell me no. If you agree, not necessary to say yes. Anyway, we now know the distance. We also remember here, lambda is one distance from one maximum to the other maximum. So if we, this distance, divide by this small wavelengths, we shall have k, which will be number of maximum over that distance. Now, number of maximum, which is counted during time of 1 second, is called frequency. It's definition from physics, from technique, from whatever, technology. So frequency is number of periods or vibrations for 1 second. So which means that right now, this k, if t equal to 1, this k will become frequency. So frequency will be c divided by lambda. Now we shall a little bit modify our experiment. In this experiment, at the time 0, wave started to go in this direction. But simultaneously, our detector, our boat, also started to move with a speed v in this direction. Now what we have? We have the same. Our wave passed through this distance. But our detector passed the distance which is equal vt, which means that these blue maximums were not counted. They simply didn't get to the detector, which means that only this maximum were counted. In order to express it in mathematics, we have from this distance, subtract this distance, correct? So it will be ct minus vt divided by lambda. And so, which means that in this case, you see this, ct plus minus vt divided by lambda. Plus or minus because we moved, in this case, frame in this direction, but we could move it in this direction. If we moved in this direction, instead of subtraction, we have to add periods, because additional periods will be counted. So basically, if we remember that c divided by lambda, we told before, is frequency, we get Doppler formula, which is f observed by frame of boat is equal to f original, which is a steady state frequency, multiplied by this bracket, which is 1 plus minus v divided by c. So we got Doppler formula, which was published in 1842. And this is called Doppler formula for collinear movement. Collinear, it means that movement along the same line, which means that we move frame either this direction or this direction, but along the same line. So this is already much more than enough for your school or university, whatever, Doppler effect. But I would like to make it a little bit more interesting for you. Next, what we should do is we should consider what happens when V and C not collinear, when there is angle. Probably you saw plenty of time. You stay on the beach and wave come not exactly to the, but with a little bit angle. It happens when wind and current do not coincide. So it's called non-collinear movement. This just, I took a couple slides. This is just ocean, but this is a facility of the university. It's pool. It's pool, and this wall vibrates and create waves. This wave called linear. It is called linear because you can notice that maximum of the wave, and here also, it's straight line. That's why we call such wave linear. But for theoretical analysis, it's better to use a diagram. Now we look at this wave from the top. In order to make it a little bit easy to imagine, I put here isometric view. It means that, you see, this is a maximum wave, red lines. And here is a minimum. This is the same. This is the maximum of the waves. and green lines is a minimum of the wave. But we now, in this picture, we look from the top. So basically it is the same as previous experiment. If our detector would move from E to C, we know formula, correct? We just produce it and we're sure how it works. But now it moves from B to C. We need to produce formula for this case. So we prepare a new experiment. Experiment is the following. We take this pool, rectangular pool, create waves inside this pool. You see red, green line. And now we cover it with a plate, semi-transparent piece of plastic. But in this plastic, we make a slit. One slit from B to C and another slit from E to C. This plate is fixed to the pool and stay. These slits and plate is necessary to make sure the detector, which I marked with a small circles, black circles, it can move only in this direction, and another detector move only in this direction. But after that, we create another plate, and this plate is not fixed. It can move. It can move in this direction. In this plate, in second plate, we create one slit, this BE, horizontal slit. Now we just observe. We started our detector, and we observe, let's say, an oscilloscope or with the eye, whatever. I prefer, with your eye, because I'm trying to teach you how to make abstraction view or abstraction check of the idea. So you do not see the spool, but now you can imagine what is spool, correct? More or less. So now we're trying to observe this detector and this detector. First of all, detector stay and wave moves. Each time next wave comes to this position, both detector B and E fix it, measure it simultaneously, absolutely simultaneously, because this wave is parallel to our slit. Each time it comes to E, it simultaneously comes to B. Now we started to move our slit in this direction with the speed V. Whole plate we move in this direction, but because of this slit, this detector moves here in this direction, EC. But this second detector moves along this line, BC. This shows when it moved a little bit, and you notice, because it's parallel, it's still both minimums cross both detectors at the same time. We move here, next maximum, and cross at the same time. We move forward, and at the end, by the very end, so anyway, at the end point, at C, these two detectors coincide, which means that they measure waves simultaneously. So, all the time, this wave cross simultaneously point B and point E. But you also notice that time was the same for movement, but distance was not the same. This distance was bigger than this distance, which means that this speed was bigger than this speed. And remember, this speed is not CT. CT is from A to C. This is the speed of our collinear detector, and this is not collinear. In order to find our formula, what should we do is the following. We have to substitute in our Doppler formula, this formula, which is for this detector. We have to substitute with another formula for this detector. And speed difference is, if you want to see, if this speed, V, times cosinus theta, it will be equal to this speed. In this case, mathematical expression for the simultaneous movement will be V cosinus. So, in this formula, Doppler, we instead of V put V cosinus. So now we got formula of the Doppler for non-collinear movement. So now it's totally finished. So nothing else we'll find anyway. In school, in university, Even if your doctor professor asks your physics professor, nothing. So now I will teach you something else, something totally new. Now we take the same pool, but the wall in the pool now is not horizontal, not like this, but with a slope. We put a little bit slope. So our ball is in this position and still move like that. It creates waves. Now the waves not perpendicular to the propagation vector, but with a slope. What happened in this case? Try to imagine the same experiment as we did before. We make a slit here, BE, and it is horizontal, exactly like previous experiment. We know that at this point, both detectors coincide in the position and will measure the same wave. But here, this is at the maximum and this is at the minimum, which means that if we move it simultaneously, they will count different number of waves. So previous formula is not good enough. Right now, I'm trying to put your attention to one thing. Formula is not important. Method, what is important? So if you good student and want to understand what it is, you will open your book and you will open Wikipedia. What Wikipedia will tell you? What books tell you? They will tell you, you need to take this point because projection of this vector on this line is what makes correct result. So it is not correct. Now you have a choice. Either you believe in your book or you have your brain. If you're computer, you believe the book because computer, oh, I know that some of you believe in artificial intelligence. Believe me, computer will produce result exactly the one which is programmed inside it by human. If you program Doppler, it will produce you Doppler. You need your own brain to understand. So if you remember methods, which I try to explain you, we need to put slit not horizontal, not vertical, not some other place, but exactly above the wave maximum. So slit should be now like this. In this case, at the start, the slit is here, and here, they are at the same maximum. They continue to move, and always at the same maximum, and finish at the same maximum. Which means that Doppler formula should be a little bit modified. Now it doesn't work. So Doppler formula is correct only when waves linear and like this. For these waves, it doesn't work already. In order to calculate new formula, all you need is to calculate. So you know that this CE is VT cosinus theta, correct? Remember. But we need to calculate this. In order to calculate this, we first calculate BE. BE will be VE na sinus theta. This V sinus theta. And in order to calculate this one, it will be we need to introduce this angle. Angle at which our waves is turning. This angle phi. In this case, if this angle is phi, then dE will be equal to this times cotangents of the phi. And so this is a correct formula. I have to do it a little bit like this. Now you see, this is formula V cosinus theta, but we have to add this one part, sinus theta by cotangents phi, in order to take into account slope of the waves. This is a new formula, you will not find it anywhere. Now, in the next step, this was all theory. I was trying to teach you how to understand, how to imagine, how to abstract, and how to find correct formula. Now let's try to think about real application. You know that radar, sonars, and every other kind of device, they use electromagnetic waves. Sooner or later you will learn electrodynamics, and you know Maxwell equations, and you know that all electromagnetic waves are spherical, circular. So they are not linear like in previous. If you take a look at, it's here, I think. If you take a look at Wikipedia, this is a page from Wikipedia I just opened, you notice that they draw spherical waves all the time. But formulas they use is still the same, Doppler. The question, is it correct or not? Let's see. In order to do this experiment, it's better to make animation, but in this program I cannot make animation, it's from Blender. But anyway, in order to generate spherical waves, or circular waves in this case, you need small piece of, let's say droplets go into water, you know, it creates spherical waves. Or you can move some kind of piece of metal up, down, and it will create that kind of waves. These waves are called spherical, and you understand the reason, because it's circle. Any cross-section of it will be circle. Now we shall take a piece of this circle and try the same method. So we do our experiment. We produce waves. Red lines is a maximum, green is a minimum, and we try to calculate correct formula for this. If we once more do as book tells us, make this projection, CE, what shall we get? When this detector moves from E to B, and another detector from C to B, it's easy to notice that this maximum and this green line will not be counted by E because they move faster. They move away. Only these waves will be counted. But this detector, it will count these waves. And then this also. So, idea of projection is not correct. You cannot use it. And that's the reason for mistakes. And by the end, I will show you why American F-35 is called drunk plane, and why F-22 is not good enough. That's the reason. It's a mistake. Now let's try to use our method. And our method is we make slit, but not horizontal slit, but slit which goes over wave maximum. In this case, it will be circle slit, like this, slit from C to D. In this case, you notice that this will close 1, 2, 3, 4 in count, and this will close. It crosses exactly the same waves. So we shall get correct result. Now, in order to express it mathematically, you need a little bit of geometry. I don't know how good you are, so I will remind you. In order to calculate this BD, instead of this VT, we have to calculate this distance, BD, in the same, with the same arguments. So we first calculate CA. We know that this AB is called CT. During the same time, 1 second, electromagnetic waves come from here to here. Detector comes from here to here with the same time, but with the speed V. It will be VT. So this AC, we can calculate on the cosinus theorem. Do you remember cosinus theorem? No, you don't remember. Oh, you remember. Good. Anyway, if you don't remember cosinus theorem, it's also good because actually you can make this triangular, and it's not rectangular triangular, but you divide this into 2 rectangular triangles, 1 and 2nd. And you can calculate using Pythagoras theorem. Do you remember the Pythagoras theorem? Good. If you remember Pythagoras, it will be just twice more calculation. But basically the idea is that AC, whatever you calculate, is it will be this expression. CT in 2nd power, VT in 2nd power, and minus 2 VC cosinus of this angle. It will be AC. Now, let's remember that this is a radius. It's a radius of the same circle, which means that AD is equal to AC. And in order to find BD, we need from CT subtract AD. It's the same as subtract this one. So basically this is written what we did. And if you finally just make this very, very simple, 1 plus 1 minus 1, cancel all the ones, you get this formula. So which means that in case of spherical waves, Doppler formula is not correct. You need to use this formula. This formula is produced by one very young scientist, but it's not yet published. So if you want to ask any question, you can ask me. Nobody else will explain you this. It's new science. I decided that it will be interesting for you to know this. So you're kind of the first in the world who, not first of course, I would say a couple dozen scientists saw already this presentation, but you are among the first who understand, who know this. But I'd like to remind you once more, don't please try to tell the formula if you are not able to explain and prove it. Because if you tell that Doppler is incorrect, you will get 0 on your exam. And nobody will help you at all. So if you try to repeat something like that, you better understand it. You should be able to reproduce this experiment and exactly explain how you got it. And now a little bit a little bit different part. I'll try to show you something else. Basically, this is the end of theoretical presentation, or experimental if you want. But now I want to show you something else. Let's say, take a look at this. This is a kind of publication. If you want, I can show you where it's from. It's kind of military review. You can find it. Oh, what happened? Oh, it worked. You see, this is kind of military review, whatever. I just wanted to know that it's not that I invented. But you see, the name F-35 pilot C double, but it's planes that drunk. Probably not. You do not follow military reviews and whatever arms. Idea is that, oh, but you probably know there is no 3G GPS. GPS work only on the surface of the Earth. Even more, GPS has error, which is dozens of the yards. It's huge error. When you use phone, it's not GPS that you use, it's differential GPS, which means that in order to decrease the error, your GPS make reference to high building or to mountain, to river, to the road, and then decrease. Most used reference is the cellular stations. So distance to cellular station is very short, and mistake in Doppler is small. And that's why inside the city, you can get pretty much accurate GPS signal. But you move to the desert or to the ocean, and GPS gives you miles of error. You try to go into three-dimensional like plane, and you know, plane when try to use GPS, they land in different wrong cities. So it's absolutely awful result. But of course, last 10 years, every year scientists, especially computer scientists, they tell one thing. All we need is to get better computer, because better computer will give more precise result. We still have a little bit of time. Okay, I'll try to explain you what's happening here and why it is drunk. One thing you should understand. When I look at the distance, and I can tell that this distance is like 6 yards, if I try to see it with one eye, I try to see differential, reference to the wall, to something. If it is one object in space, in order to see the difference, you need two eyes. In this case, your brain compare distance between eyes to the distance to the object, and more or less calculate the distance. That's how it works. Now imagine plane. Plane in the somewhere flying high in the air. In order to get accurate picture, three-dimensional picture, to know the distance, the speed of the enemy, you need signal from two planes. You cannot put two radars on the same plane. There should be distance between them. It's like triangular should be. The more is the base, the more correct data. So F-35 was supposed 10 years ago to use system that is called advanced sensor fusion, which means that signal from two or more planes or from ground radar and plane combined. It's combined in supercomputer, and this combined picture should create three-dimensional field of view. Now let's try to understand why it is wrong. First of all, I wanted to tell you about the error, how big error modern radars and GPS has. Some people, especially professors, they're so sure that they are good, and they tell, oh, V divided by C is the speed of light, and V is the speed of plane. The difference million times. So it's very small error. Now let's see if it is small or not small, because otherwise it is not science. It's religion or politics. Politician tells, oh, you good. No, you bad. I don't believe you. You understand? It's not science. If you don't believe, it's religion. If you want to make more loud statement, it's politics. In science, you should calculate. So, this is the Doppler formula for this case, non-collinear movement. This is the formula that we produce right now. Now let's try to see what happens in real life. We have one radar that measures the distance. So it measures first of all frequency, which is observed. It also has frequency, this one, which radar sent. So basically, if we divide both sides, F observed by F0, we have the same signal from the same radar. But we process signal with this formula and with this formula, which means we try to put them against each other. In order to solve it, we put this into second power. You see? Now, you see 1 and 1 is crossed. This 2v divided by c cosinus delta, 2v divided by c cosinus theta is the same expression, except we introduced for us new angle. I will explain a little bit later. They are very close in this case. In this case, exactly it is the same. But there are cases when they are not the same. So if we cross this first two parts and this first two parts, what we shall have by the end is a very simple expression. The speed which you find with our formula, new formula, is equal to the what radar found times cosinus theta, which means that if your plane fly exactly behind or opposite to enemy, you get exactly his speed and position. But let's say cosinus theta equal to 60 degrees. The error will be 2 times. It's huge error. Remember Star Wars? Did you see Star Wars? There was a piece where fighters want to destroy Death Star, remember, yeah? And so allied against enemies, and they fly behind each other, and one pilot over radio says, "Other, why didn't you shoot him? I cannot lock the target." So phrase, lock the target. Do you understand it? If not, I will explain. Radar sends signal, radio. From this signal, it tries to locate position of the enemy. If it locates position, then it tries to follow him. If it can follow it for a couple seconds, it's called lock the target. After that, it can send missile, or in that case, shoot laser. But if you think that you locked, but in instant it is not locked, it is out of your sector of view, it is not locked. So, because of this error shows when they follow one another, they can shoot each other. But if one of the plane go this direction and angle always is big, you cannot lock the target. So meanwhile, it means that this formula, I mean our formula, will not be discussed in next, how many, 5,000 years, yeah? Or million thousand years. I don't remember how many. Star Wars, it's million times years later and million miles away, yeah, beginning. So it means that they, in spite of all their star and whatever their stars, they still didn't discover this formula. Because with this formula, they could lock your target at any place, at any angle. There will be no mistake. Now let's take a look how it looks. So this is radar. It sends signal. In first case, it measures frequency. From frequency, it calculates speed of the target. But it also measures azimuth. It means direction to the enemy. From this frequency measurement and this cosinus, according to the Doppler, it will find position of the enemy here. But if it would follow our methodic, from the same E, it would find position of the enemy here. Now, what happens now? F-35 is the latest military plane, different from F-22, which is the best flyer, and also the best whatever plane US has. The difference is computer and communication link. You know what communication link? It's like modem, like your Wi-Fi. Idea is, in order to process this information, F-22 is trying to do it with its own computer on the board and cannot. F-35 also cannot, but it sent information to US air base. And huge supercomputer recalculates position and sent it back. And now it gets accurate position. If link is fast, it can get fast, accurate result. F-22 cannot because it's not fast link. But F-35 can do. So it finds supercomputer calculate and find this position, while actual position is this one. Now take a look what happens next. You see it's the same picture, but here is radar. And here is almost invisible. You see like F-35. It's stealth technology. You cannot see it, almost. So it sends signal and combines signal from itself, from radar, and from radar somebody else or other plane. According to this calculation, from frequency measurements, it finds a plane here. If it uses new method, it finds it here. For this radar, the same calculation produced it here. That's why when signal to system which called fusion, information fusion, combine signal from here and from two radars, it get instead of one enemy plane, two, and it's both of them at wrong position. That's why this system was developed after 10 years and I don't remember, $2 billion and was accepted, approved. I would say last year, beginning, almost year and a half ago, it was approved and paid for to Lockheed Martin. And after that, it was forbidden to use it. And right now, it is forbidden to use it. And if you took a look at budget office, you will see that another $12.8 billion is issued to Lockheed Martin and Air Force in order to solve this problem. So they believe that they can solve this problem by improving computer, make it even more powerful computer. But from point of view of mathematics, when you have poor computer, instead of seeing plane, you see area, rather big area where it is. With a fast computer, instead of one measurement, you do million of measurements. And error of calculation is square root of number of measurements. It's from statistics. If you don't know, believe me. But anyway, so instead of such big area where it could be, we find exact position. Now they will put even better computer. And they're going to find this, measure this position with accuracy of centimeters, like half inch. but it's still wrong position. And that's something that nobody understands. As a result, if two planes combine their radars, they have two enemies. Imagine couple US planes, couple enemy planes, Chinese, Russian, whatever, but pilots see, oh no, they're not two, they are 4 or 6, or plenty of them go. So what should the American pilot do? They are 2, and enemies maybe 6, maybe 8. They have to ask ground force, and they told, no, you cowards, there are only 2. Why you tell 6 or 8? But it's because plane is drunk. Anyway, I hope I entertained you a little bit. And hope you understand that right now people at the top are very stubborn. I'm trying to tell that we presented it a year and a half. I mean, with my son, who is after this. We presented it in Washington. They agree that it's good, but they told that it's science, pure science, and it should not be patented. We wanted to get patent. We didn't. Anyway, you now understand this, but that is not the most important part. Most important part of today's presentation is, you see formula. You have 2 choices. Either you remember, and then you can go to whatever Victorian, who want to get million, because they check who remembers what. Baseball players, formulas, whatever. But if you want to be scientist, if somebody will tell you, do you remember theory of relativity? If you remember, it's nothing. What to remember? One formula. Either you understand or not. In order to understand, you got idea. So goal of today's presentation was to give you idea how to become scientist. You take whatever phenomenon, you try to understand. In order to do this, you remember how it was discovered, what kind of experiment made the guy, what kind of ideas was in his brain, and you try to reproduce. If your brain is strong enough, you can reproduce it in your brain. It's called abstraction view, whatever, abstraction thinking. If not enough, take a pool, take a method, take a whatever, create some small kind of instrumentation and try to reproduce. If you now understand actually that it's true, then good, you can move forward. If not, don't tell anybody, and first of all yourself, that you understand. It's not understanding. And remember, when mathematicians tell that multiplication V by C is small thing, because C is small, V is small, it's just word. Small, it's not mathematical symbol. It's not multiplication, not division. Small, it's for politics, for something else. If you're scientist, whatever, you should calculate. It is the same physics, biology, whatever. And I can tell you, because you see, I'm doctor in physics, doctor in mathematics, but 30 years I'm teacher at the chemistry department. And right now I have to switch to biochemistry, and so this is my old specialty. So I know exactly what's all. And I'm trying to tell that if you will be good at understanding phenomena, at making experiment, whatever is education, you can do anything. Physics, chemistry, biology, astronomy, whatever. Right now, when comets or something go to Earth, and they told, okay, we calculated trajectory, accuracy of calculation is about 1,000,000 miles. Because Earth goes around on the circle, almost circle trajectory, and comet goes straight forward. So angle is quite big. Until they somehow align, nobody can calculate even close to accurate whether it will be hit or not. I mean, Earth will be hit or not hit. Anyway, I do believe that for today it's quite enough, because the rest, of course, I can continue plenty. This is less than 1/10 of the presentation. But the rest of the presentation is a little bit more complicated. You just, one more thing that I would like you to remember, that whatever formulas, when we get formula for the not perpendicular waves, but with the slope, you remember that if cotangents become equal to 0, in this case, straight angle, you will get back to the original Doppler formula. So formula which we produced are more general. And in this case also, if you try to see what shall be when collinear movement is, all you have to do in this case, this will become 1 is a plus or minus. This expression will be simple 1 plus or minus this, because of cosinus will change sign. And you will get simply 1 plus minus b divided by c. So we get back to the original formula of Doppler in case when v and c perpendicular, when movement is along the same line, collinear movement. So basically what I'm trying to say is that these formulas not contradict to original, to the very, very first Doppler formula. But Doppler formula is correct only for one direction. One. Try change a little bit direction, and the more slope, the bigger error. Okay, I see that you're already tired. If you have any question, I will be glad to answer your question. If about this, it's first of all. If not, you can ask about physics, chemistry, biology, mathematics, nuclear physics, fusion, whatever. I can explain you most of that. If not, then last point I would like to tell you that on my estimate, like more than half of all publication modern are mistaken. More than half, just think a little bit. You are the new scientist. So it's plenty of job for you to correct it. Mistake is almost anywhere. Everywhere you look is a mistake. But don't think about everything as mistake. Try to think about it as opportunity. I just a couple minutes ago heard a presentation about fusion. Like two hydrogen fuse and give plenty of energy. So two hydrogen will not fuse. On plenty ideas. First of all, in order to fuse, they push, Coulomb force, you know, two pluses, they push in the different direction. They will never stay together. In order to stay together, modern science says somebody needs to put gluons. Gluons, it's tiny particles, which nobody saw, measured, or seen, but it's glue these two hydrogen nucleus into one. So of course, modern science says they glue because they have no other ideas. But probably you should have two ideas, and ideas on the surface. It's very simple to explain, and I know this explanation. I don't want right now you to go into details. It's not for today's presentation. But I'm trying to say that sources of energy, which is a billion and many billion of times more powerful than atomic energy, are around us and quite easy to get. And this is 21st century is the time to get it. And you're a kind of person who are going to do it. But if you become mathematician, and probably you are going to become because you're in Courant Institute, remember, no one single formula in mathematics is correct until you have exact physical idea. And by the physical, I mean not exactly science or physics, but our universe. It means that if you do biology experiment and you calculate something in biology, you have to understand exactly what's going on there. You have to have model in front of you. You do chemistry, you have to understand why. Why two molecules attract? You understand, nucleus trying to push away. Electron, nuclear attract. And so you have to find the balance, how molecules stay. Formula means nothing until you have very, very good model idea. And then, only then, comes understanding. Okay, that's it. I don't know what else to tell you. Thank you. Thank you.